This is on reading z-scores, which is very important from now till the end of the course. So you really need to understand this. Okay, so take your time. My biggest advice is draw a picture, draw a picture, draw a picture, and you'll see what I mean by that. In your book, there are two tables. There's a table for a negative z-score and a table for a positive z-score. The negative z-score are the values that are to the left of the mean. If we're standardizing our mean at 0, and the reason they do that is you can't have a table for every single mean. You have an average of 5, I have an average of 47, somebody else has an average of 2,000. So what they do is they say, let's do this z-score and standardize to a mean of 0 and a standard deviation of 1, and then all we have to do is use this one table. Alright, so reading the z-scores, again, if I'm to the left of 0, it would make sense it would be a negative value. This area under here is probability, and that's the 4-digit values that you find within the table. So the z-score column tells you how many standard deviations, in this case being negative, you are below the mean, and the 4-digit value tells you the probability that you would find that value, that many standard deviations below the mean. Then of course we have positive z-scores, which says now we're above the mean, so it would make sense these would be positive values because they're greater than 0. I mean, as you can even see here in the table, at a z-score of 0, this is half of the data. So half of the data up till your mean, and the other half there, because you know all probabilities have to add to 1. So let's look at, this is question number 9 in assignment 4. It says, assume that z-scores are normally distributed. As soon as you see that, you draw a picture. What do I mean by drawing a picture? Draw a bell-shaped curve. Put a line right down the middle and put a 0 right there for your mean. Okay, a mean of 0 and a standard deviation of 1. It says if p, the probability of z is less than a equals 0.9474, find a. Well, what in the heck does that mean? And we're doing part A. This means find the z value that is 94.74% of the data. Well, if I know from here to the mean is 50% of the data, or let's keep it in decimal like they did, then I know this 0.9474 is somewhere beyond it. Okay, so in other words, all this shaded area under here would be 0.9474 of the data. Well, what is this value right here? That's what they're asking you to find, and that's the z value. This is what you look up in your table, and so we go to our table and we find this value, 0.947. Here we go. I look for 0.9474 and I find it right there. This tells me that my z value is 1.6, sorry I didn't mean to mess it up there, plus 0.02, which would be 1.62. Well, that makes sense because that was to the right of the mean, and it would make sense it would be a positive value. All right, let's do part B. It says, if z, the probability of z is greater than b equals 0.9812. This says that you have 98.12% of your data above your z value, meaning that you have something more like this, and all this area is 0.9812. The problem with your table is it gives you this area right here. So what you have to do is, you remember, all probabilities add up to 1. You just simply take 1 minus this 0.9812, and you should get 0.0188, and that's the value you're looking up for the z-score in the table. As you can already guess, you're going to go to the negative table because this is below 0, so it has to be a negative z-score. Negative table, I look for the value that is closest to 0.0188, and I find this at a negative 2 minus 2.08. In other words, this is saying you're below the average over 2 standard deviations. depending on what your data set is. Moving right along, part C says what's the probability of Z is greater than C equals 0.0409. Okay, again, this is a Z value greater than, so we're looking at a probability to the right, meaning a little section of this data here, 0.0409, because we're saying that this Z value is greater than this amount. And so again, how do you find this? By our table, we have to look up that area. How do you find that area? 1 minus 0.0409. You should get 0.9591. I go to my table. I look for 0.9591, and I find it right here at a 1.74. Again, would make sense. I have to have a positive Z value. Okay, so remember, all you're doing here is you're saying, oh, well, I'm above the probability that I'm going to be above the average. 1.74 standard deviations is about 95% of the time I would be above that. So, or I should say above would be the 0.04%, right? That I would be above it. Below it would be that 95%. Sorry about that. Okay, part D now says I'm looking for an area in between. Think about this. You might say the class average is 87. You could be above or below the class average. And so that's what we're looking at here. So this says I have some area, and in between here, this area is this 0.5588. Okay, I'm still doing the same exact thing. I want to know what this Z value is and what this Z value is. I know this one's going to be negative, and I know this one's going to be positive. Again, looking at my table, if I find this area, because that's what's in our table, now notice I don't subtract 1, because here the problem is I have 2 pieces on each side. So the easiest thing to do is to divide this in half and figure out how much area is in this side and how much area is in this side. And it'll be the same area, right, if you're dividing it in half. And you should get 0.2794. So that says this area right here is 0.2794. Well, now how do you get this area? Well, we're only halfway of our data, so I'd take 0.5 minus 0.2794, which would equal 0.2206. Sorry for the messy drawing. Again, this is why you want to draw these. You want to draw these. So I'm looking up 0.2206. Well, what about this value? Well, this value, I actually could take this entire piece here, okay, which would be 0.5588 plus the 0.2206. Okay, so I could take 0.5588 plus 0.2206, 0.2206, and I get 0.7794. And so that's the large area. Well, what you're going to see, and the key that you need to recognize, is this curve is symmetric. So whatever you get to the left, you should get the same value to the right. So if I look up 0.6, 0.2206, I get minus 0.77. Well, if what I told you is true, if up 0.77, what was my, I've already forgot my number, 94, I get positive 0.77, and so that worked. And so that's a good indication, and something you really need to understand, that curve is symmetric. When you're looking at area in between, this is going to be the minus and this is going to be the positive, and they'll be the same. All right, you got this down. You should be able to try part E on your own right, meaning that we're looking at this area here is 0.2206. Kind of do the same thing, and I've learned now this is minus z and this is plus z, so I can just look up this one. I can just look up this value by dividing the area by 2 again. I get 0.1103. That's this red area. So then this lower area here would be 0.5 minus 0.1103, and I get 0.3897. Up in the table, 0.3897, and I find right here it's negative 0.28. Within the right side of that would be a positive 0.28. And I'm done.